So we're going to quickly try to understand what does wavelength mean and what does frequency mean. I've kind of labeled it here. Now the wavelength is essentially the distance between two identical points on a wave. Okay, and the frequency is how often something is moving backwards and forwards. It's how many times per second, in fact. So we'll look at an animation now, actually. So if we go over to, where is it? Over here, we can open up the animation. We want to click Oscillate, No End, turn Damping down, and we'll put Slow Motion on, just so we can see it more easily. And what we're going to do is we're going to play around with this amplitude now. If I increase the amplitude, the wave gets taller, but the frequency ends up the same frequency. Now, if you wanted, so we've got a high amplitude here, and I can measure the amplitude by pausing it and getting a ruler, and you measure the amplitude from the middle point. So this point here is where the string would be if there was no wave. So if there was no wave, the string would just be like this. In fact, I can demonstrate that by just going to manual, and there it is. So the string is now just, or the whatever it is, a necklace or something, it's just flat along there. And if I set up an oscillation, then when I start the oscillation, then it's going to move from that point. And so this dotted line is where the string would be if there was no oscillation, if there was no movement. So we can measure the size of that wave using this ruler here. Actually, we need to just move it up so we get a 0 there. And it looks to me like the ruler is, well, it's about there, isn't it? So it's like 1.2, maybe 1.2 centimeters. And then we can also measure the wavelength, which is the distance between two identical points. So I can measure between a crest and a crest, or I can measure between a trough and a trough. So the trough is the bottom thing, and the crest is the top, like a valley and the top of a hill. And so the wavelength of this is 4.2 centimeters. It looks like. So and so let's press play again. And now we're going to increase the frequency, and let's decrease the amplitude. First of all, when we decrease the amplitude, it doesn't change the wavelength. If I measure it again now, it's difficult to see because, well, let's press play again. Again, still measuring it at about 4.2. So from there to around about here, still 4.2. So what we're going to see now is how does the wavelength affect when I change the frequency. If I increase the frequency, this is now going up and down more quickly, but the wave is moving at the same speed. So in the time it takes for the wave to get this far, it's managed to complete one whole oscillation. And so the two humps are going to be closer together. So now that's around about 2.5, I guess, 2.5. So a high frequency produces a low wavelength. And a low frequency, if we do a low frequency now, a low frequency will produce a very long wavelength because it's going up and down so slowly, but the wave itself is moving still at the same speed. I'll reduce it, if I make it just a little bit taller, a little bit faster, we can see now that the wavelength is a lot longer than before. Now I'm measuring just a little bit longer actually, but yeah, nearly 5 centimeters. So that's how you measure the amplitude and the frequency. Now this is the same with all waves, and the thing about this is that their sound is a wave, and so is light. And of course, this is just a wave on a string. You can also have water waves, and you can have other types of waves as well. But we're trying to understand how we see and how we hear. We need to understand what waves are, and then we need to understand what light waves are and what sound waves are. So, so if I come out there then, we go back to this diagram here. This wavelength is, if it was light, although we don't see a wave, when we look at light, we don't see a wave, we just see light. But the difference is that a wavelength in light, if we have a look here, these numbers represent the wavelength. In this case, they're very, very tiny, but there still is a wavelength. And what it says is that a lower number is blue and a higher number is red. So, and then we have the ones in between, right? So that means that in light, if we have a smaller wavelength like this, then our brain basically our brain translates that into blue, and we see the color blue. Whereas if it's longer, our brain translates that into red. And if it was somewhere in between, then our brain would translate that into the colors in between, right? So then let's make it just a little bit faster, like that. So again, this is the wavelength here. That's the wavelength from one to the next. What color is this? And this one's a bit shorter, and this one's the longest one. Now we can. There are other types of waves, and in fact, the wave that was coming out of that remote control. So, if I were to get my remote control and point it at the camera, like I did earlier on, then you can see a light, but that's because basically what's happening is this remote control is producing infrared. Now, infrared is just like any other wave that we see, apart from we can't see it. See, our eyes can only see the tiniest little amount of wavelengths. There's actually loads of waves going on all around us all the time. And this is only one type of wave as well. These are called electromagnetic waves. So and in fact, this pattern we see below us, this is called the electromagnetic spectrum. And what that contains is all the different types of electromagnetic waves. And the tiny little fraction is what we can see. Well, we can't see any of that stuff in grey. And of the things that we can see, the short wavelengths we see as blue, and the longer wavelengths we see as red, and the ones in between are the other colours. But if it got even shorter than this 400 here, then we can't see it. And if it got even longer than that 700, then we also can't see it. So we can see that anything longer than that between these two, between this wavelength and this wavelength, we call infrared, or it says written IR. And the stuff that's shorter than the stuff that's the wavelength is too short for us to see, we call it ultraviolet. And ultraviolet, it can be detected, but we can't see it. We can't see it with our eyes. The reason why we saw the light coming out of the remote control is because the camera on my computer is like an eye, like a human eye, but not exactly the same. So the light on my computer, it detects wavelengths around about these range, between 400 and 700, but it actually detects wavelengths slightly longer than the human eyes. So maybe it goes up to about 750 or maybe 800. And that's infrared. So that means that the lights coming from my TV remote control, my camera can see, but I can't. And what happens then is the computer monitor turns the information into an image that we can see, and then we end up seeing light. So the infrared that's coming from the TV remote control is turned into light from the computer monitor. So that's why we can see that there. So I'll just stop that little video there.